Hello guys, welcome to another video. Today we're going to work in topic 7, atomic physics. We're going to work in a couple of multiple choice questions. So let's jump straight into the problems and see the solution. So number 1, it says that the energy levels for an atom are shown to scale. So here we can see the different energy levels as the energy is increasing. A photon of wavelength lambda is emitted because of a transmission from E3 to E2. Which transition leads to the emission of a photon of longer wavelength? So now what we want to do here is to increase the wavelength and see the transmission. But when you increase the wavelength, you know that you decrease the frequency. And now based on this equation, if you decrease the frequency, you decrease the energy as well. So you are looking for an energy transmission with a small energy difference. So of course here it's E4 to E3. So the correct answer is B. Number 2, a proton, an electron, and an alpha particle are at rest. Which particle has the smallest magnitude of ratio of charge to mass? And which particle has the largest magnitude of ratio of charge to mass? So what we can see here is we have to compare this ratio between charge and mass. Now for the electron, we know that we have minus 1e charge, and let's call it 1 small m the mass. For a proton, you have plus 1e charge, and you have 1, let's call it capital M, because this mass is way bigger than the electron's mass. And now for the alpha particle, you have actually 2 protons and 2 neutrons, so you have plus 2e charge, and you have 4 mass for the mass of the alpha particle. So the ratio of charge over mass, it's pretty obvious for the smallest one, that it's like the alpha particles, it's 2 over 4, so it's 0.5. All the other ones, they will give you a ratio of 1. So it's definitely A. So you see that you don't have any other option for alpha particle here, so it's definitely A. But if you want to do also the other ratios, you see that the electron has a smaller mass, so the ratio it will be bigger than the proton and the alpha particle as well. So it's the largest charge to mass ratio is for electron. Now number 3 is for topic 12, so let's keep it. Number 4, what is correct about the nature and range of the strong interaction between nuclear particles? And you have a couple of options here, attractive and repulsive. Of course, you know that it's not repulsive because the strong interaction is what holds the nucleus together. Now, it says, are particles for all separations, or are particles with separations between femtometers range? Of course, you know that this is the correct one because this is the diameter of a nucleus. It cannot be in all separations. So correct answer is B. Number 5, nuclide X can decay by 2 routes. In route 1, alpha decay is followed by beta minus, and in route 2, beta minus is followed by alpha decay. P and R are the intermediate products, and Q and S are the final products. Which statement is correct? And we have a couple of choices here. Now in order to make it more clear, let's make an example of this particle X. Let's say that it has 40 as the mass number and 20 as the atomic number. So it will decay first with alpha emission, so it's gonna be 38 and 18 P, and then with beta minus decay, that means that the neutron is converted into a proton, so it's 38, 19 Q. For the second route, first it decays with a beta minus decay, so that means that first he's gonna have 40 and 21 for R, and then with an alpha particle, so it's going to end up with 38 and 18 for S. Now it says Q and S are different isotopes of the same elements. Well, you see very clear that it's the same thing, so it cannot be. The mass numbers of X and R are the same. The mass numbers of X and R, 40 and 40, so of course this is correct. The atomic numbers of P and R are the same. Atomic numbers of P and R, they are not the same. X and R are different isotopes of the same elements. No, it's not the same element. You see they have different atomic numbers. So it cannot be true as well. So the only correct answer here is B. Of course, when you figured out that B is your correct answer, you don't have to check the other ones, but I'm just doing it in order to be 100% sure. Now, gamma radiation is deflected by a magnetic field. Of course, not. It affects a photographic plate? Well, of course, yes. Originates in the electron cloud outside the nucleus? Of course not, because it can originate also in the nucleus, inside the nucleus. Is deflected by an electric field? Of course not, because it doesn't have charge. So the only correct answer here is B. Number 8. Which property of a nuclide does not change as a result of beta decay? Where in beta decay, you have either a neutron converted to a proton, either a proton is converted to a neutron. It depends on the beta plus or minus decay that you have. So of course here you can see that the correct answer is A. The nuclear number will always stay the same. Number 9. The rest mass of the helium isotope is M. Which expression gives the binding energy per nucleon? Now, the binding energy per nucleon, this is important, it is the total binding energy of nucleus divided by the number of nucleons in the nucleus. So of course here it cannot be C or D because we have to divide with the number of nucleons. Now the total binding energy, it's gonna be given by the mass defect times C squared, the most famous equation in physics. Of course divided by the number of nucleons. So the mass defect is the mass of the individual particles minus the mass of the whole atom. So what you have here, you have two protons, so two masses of the protons, plus one neutron minus the total mass of the atom. So minus M, and all of this is multiplied by C squared, divided by the number of the nucleons. There are 3, as you can see here. So of course the correct answer here is B. Number 10. Which of the following atomic energy level transitions corresponds to photons of the shortest wavelength? So what we have here, we have short wavelengths, so that means bigger frequencies. So from this equation, as we saw before, the energy is the greatest that we can have. So the bigger energy level transition, you see it's your choice of C. Number 11. A radioactive nuclide with atomic number Z undergoes a process of beta plus decay. What is the atomic number for the nuclide produced and what is another particle emitted during the decay? So what we have here, we have beta positive decay. So the proton, it converts into a neutron and it gives you also a positron and a neutrino. Sorry, this is plus. So from here you can see that the atomic number, it's gonna be reduced by 1, and also the other particle that is gonna be emitted, it will be the neutrino. So correct answer here is A. Number 12. The position of stable nuclei are plotted by neutron number N and proton number P. The graph indicates a dotted line for which N is equal to P. Which graph shows the lines of stable nuclides and the shaded region where unstable nuclei emit beta minus particles? So first of all here the dotted line, it shows the zone of stability. Now we'll talk about beta minus particles that they are emitted, so definitely you are above this line in this direction, and also you know that the more stable nuclei, they have bigger number of neutrons of protons. Well, the most stable ones, they have the exact same numbers, but a nuclei with more number of neutrons, it's more stable than a nuclei with more number of protons. So it cannot be B or A. And now you need to see the shaded region where unstable nuclei emit the beta minus. So in the beta minus, as we have said, that the neutrons convert into protons. So from this area, with bigger number of neutrons, you need to move to the area of almost equal numbers of neutrons and protons. So of course this is the shaded area that it gives you the correct answer. Number 13, it says that we have three conservation laws in nuclear reactions. Conservation of charge, of baryon number, of lepton number. And we have this reaction. A neutron, it converts into a pion negative plus a positron plus an antineutrino. Which conservation laws are violated in the proposed reaction? So what we need to do here is to check each of those laws and see which one is violated. Now, we know, in order to do that, first of all, we need to know that the neutron, it consists by one down, one up quark and two down quarks. Also, the P minus is consist by an up and the up quark and the down quark. Now let's see the conservation of charge first. Neutron, it has 0. P minus, it has -1. Positron, it has +1. Neutrino doesn't have anything, so +0. So you can see here that the charge is conserved. Now the baryon numbers. So the up quark, it has a baryon number of 1/3. The anti-up quark, it has a baryon number of -1/3. And the down quark, it has a baryon number of 1/3 as well. So the neutron, it has 2 down quarks and 1 up, so it has a baryon number of 1. The pi minus meson, it has an anti-up quark and a down quark, so a baryon number of 0. The electron, it's not baryonic, so it has 0, the neutron as well, 0. So the baryon number is violated. Now the lepton number, from the other hand, we see that we have 0 for neutron, it's not a lepton, 0 for pion, it's not a lepton. The positron, it has a lepton number of -1 because it's an antiparticle. The antineutrino, it has a lepton number again as -1 as well. So this one is also violated. So the correct answer here is number C. The lepton and the baryon numbers, they are violated. Number 14. Which Feynman diagram shows the emission of a photon by a charged antiparticle? So we talk about antiparticles, so what we're looking here is the arrows to be in the opposite direction of the time, so it cannot be A and B. Of course, it doesn't mean that it goes back in time, this is the way that we represent the antiparticles. We talk also about the emission, not a capture, so of course here it's the number C. Here it shows a photon that is captured by the antiparticle. Number 15. The diagram shows the emission spectrum of an atom. Which of the following atomic energy level models can produce this spectrum? Now here usually the students, they answer either C, either D. This is totally random choice and because they are most familiar with this kind of energy levels. Now what you have to see here, you have to see that when the wavelength is increasing, you have emission at these parts. So there is a big gap in between. So that means that you're looking for a big gap in between the energy levels. So of course the correct answer here is A. Number 16. The carbon isotope 146C is radioactive. It decays according to the equation, what you see here. What are the X and Y particles? Well, what we see that the atomic number here is decreasing. In order to happen that, we have beta minus decay. So in beta minus decay, a neutron, it converts into a proton and it emits an electron and an antineutrino. So of course, Y is the antineutrino and the X is the electron. Correct answer here is B. And now the last one, number 17. The P plus meson contains an up quark. What is the quark structure of the P minus meson? You see the P minus, it has an up and a down, or an up and down, anti-down, and whatever else you see. So definitely the P positive, it needs to include an up and a down quark. Now, it's down or anti-down, this is, we can figure it out through the charge, because the up quark, it has a charge of +2/3. What we want here for P plus is to have a charge of +1. So you need to add plus 1 over 3, and this is the anti-down quark with this charge. Okay, so here the structure of the P plus is up and anti-down. For the P minus now, you definitely have to have those two, but probably the opposite. So you know that you need to have a charge of minus 1. You know the anti-up quark, it has minus 2 over 3, and you know that also the down quark, it has a minus 1 over 3. So adding those together, it will give you minus 1. So it's up, anti-up, and down. So it's number C. So that was all for today, guys. This is a little bit of obscure topic. It needs a little bit of more effort in order to study that. But anyway, study hard and good luck.